What does an SD-WAN deployment actually look like? We've talked about the theory, the various planes, the processes, and even the entities that exist within each component, which actually perform all of these functions. But all of this can still feel a little abstract. So in this video, we'll make the architecture more practical. We'll look at a simple example of an enterprise network, then we'll map the SD-WAN components to actual devices, virtual machines, cloud services, and routers that you might see in a real deployment. The goal is simple: to connect the theory of SD-WAN architecture with the actual things you would see on such a network. Let's imagine a fictional company called Acme Corporation. Acme has 5 main locations. It has a headquarters where many users and administrators are located. It has a data center where some private applications are still hosted. Now, this can be on-site at the headquarters or elsewhere, off-site. In this case, Acme actually has it off-site. It has 3 branch offices, and it uses cloud and SaaS applications such as Microsoft 365, Salesforce, hosted voice collaboration tools, and public cloud workloads. Now, each of these connect to the WAN in multiple ways, including MPLS, broadband, fiber, and cellular. Acme wants to use SD-WAN to interconnect all of these locations more intelligently. So the question is, what SD-WAN components actually appear in this network, and where do they appear? First, we have the SD-WAN management system. This lives within what we call the management plane. This is the management platform. This is where administrators configure the SD-WAN environment, create templates, apply policies, monitor sites, check device statuses, and view the health of the fabric. What does this manager entity look like on the network? Well, it's usually deployed as a cloud-hosted service. It may run as a virtual machine within the enterprise data center, or it may run as a vendor-managed service in a hosted cloud environment outside the enterprise. In a Cisco deployment, the SD-WAN Manager can be deployed as a virtual machine or cloud-hosted application, where administrators access it through a web-based graphical interface or through APIs. Other vendors use similar systems. For example, Versa Networks names its management entity the Versa Director, while Fortinet uses FortiManager. Although the product names and exact architectures differ, the basic role is the same: to give administrators a central place from which to configure, monitor, and manage the SD-WAN environment. So on a diagram, you can think of this as one or more management servers or cloud-based management instances that administrators connect to. In our particular case of Acme Corporation, they've placed their management system in their own data center. Now, the manager is a single logical entity, and it must be because the whole SD-WAN infrastructure must be managed from a single location. But it may consist of multiple instances running in different areas of the network for redundancy. For Acme, one instance in their data center was considered sufficient. Second, we have the SD-WAN control system. This is the control plane controller. Remember, its job is to distribute routing topology, reachability, and policy information to the SD-WAN edge devices. What does the control plane system look like on the network? Like the SD-WAN Manager, the control plane system is normally implemented as one or more virtual machines rather than as a physical device. It may run on an enterprise data center or a public cloud environment. For a self-hosted deployment like this one, the control plane systems are normally placed in reliable data centers or cloud regions with stable connectivity to all SD-WAN sites. Larger deployments typically use multiple control plane instances, often distributed across separate data centers or availability zones, so that the failure of one system or location does not disrupt the whole control plane. In a Cisco deployment, this role is performed by the SD-WAN Controller. Other vendors use similar components. Versa Network uses the Versa Controller, but Fortinet, on the other hand, includes the functionality of the controller within its firewall devices, and this demonstrates a different architecture approach. However, the general role is the same: to provide the edge devices with the information and policies they need to establish secure overlay tunnels and make forwarding decisions. Now, this function is performed by the controller by exchanging information with the edge devices using specialized SD-WAN control protocols. We'll talk more about how this is done in a future video. For now, it's enough to know that once the edge device has learned its information, data traffic flows directly between the appropriate edge devices. Although the control service appears as a single entity in our Acme Corporation WAN, it should not be thought of as one physical box located in a single location. It's better to think of it as a control plane service that the SD-WAN edge devices connect to. Now, third, we have the orchestration function. This is also often referred to as the validation component or the onboarding function. This is the part that helps edge devices initially join the SD-WAN fabric. It helps with secure onboarding, device discovery, and initial fabric membership. What does the orchestration and onboarding system look like on the network? Well, like the management and control system, it is normally implemented as a virtual machine or a cloud-hosted service, rather than as a dedicated physical appliance, although, as you will see shortly, some vendors implement it differently. In all cases, it must be reachable by new SD-WAN devices when they first connect to the network, so it is commonly placed in a public-facing data center, cloud environment, or vendor-hosted infrastructure. Now, although we often describe it as a single orchestrator, a production deployment will often include multiple instances for redundancy and scalability. These instances are usually deployed across separate data centers, cloud regions, or availability zones so that devices can still join the SD-WAN fabric if one instance or location becomes unavailable. In our case here, we have one orchestrator in the enterprise data center and one deployed on the cloud. In a Cisco deployment, this role is performed by the SD-WAN validator. Versa Networks and Fortinet don't have a separate entity that performs only this function. The orchestration and onboarding function is divided among other functions, including the management plane and controller, showcasing the differences in approach that various vendors take. Now, what does the orchestrator actually do? When a new WAN Edge device starts up, it contacts the entity performing the onboarding using an address or hostname that's included in its initial configuration. Let's use Cisco's validator name for our example. The validator verifies the identity and authorization of the device and directs it to discover the appropriate SD-WAN Manager and SD-WAN controllers. The validator acts as the initial meeting point for new SD-WAN edge devices. It doesn't distribute routing information, it doesn't configure the edge device, it doesn't even forward traffic. Instead, it just securely introduces the authenticated edge devices to the management and control plane systems with which they must establish their permanent connections. Now, once the edge device has been authenticated and connected to the required systems, the validator is no longer involved in the normal forwarding of user traffic. Data traffic flows directly between the WAN edge devices, while routing and policy information is exchanged with the SD-WAN controllers. Now, because the onboarding process is vital and can be quite involved, we will explain onboarding in detail in an upcoming video. For now, just remember this. Before a WAN edge device becomes part of the SD-WAN fabric, it has to find the right SD-WAN environment and prove that it belongs to that environment. The orchestration and onboarding component helps make that possible. Now we come to the devices that most network engineers will physically see at the sites. These are the SD-WAN edge devices. These can also be called WAN Edge routers, SD-WAN Edge appliances, or SD-WAN Edge devices. They sit at the headquarters, the branch offices, the data centers, cloud edges, or regional hubs at any physical location that you want to connect to the SD-WAN fabric. They connect to the local WAN on one side, and they connect to one or more WAN transports on the other side. For example, branch 1 here might have a WAN Edge router connected to MPLS and broadband internet. Branch 2 here might have 2 internet circuits from different providers, and branch 3 may have fiber internet and 5G connections. The headquarters might have MPLS broadband and fiber connections. The data center may have high-capacity private connectivity and internet connectivity. The control service tells the edge devices how to behave. These edge devices are where the SD-WAN policies are actually applied to user traffic, and the user traffic is exchanged between these edge devices in accordance with those policies. In SD-WAN, examples of edge devices include the C-Edge routers, which are essentially Cisco IOS XE routers that are operating as SD-WAN edge devices. Now let's put this all together in our Acme Corporation example. Here we have the SD-WAN management, control, and orchestration services that have already been deployed. The management and control services are deployed in the data center, while the orchestration service is deployed in both the data center and on a third-party cloud environment. Below, we have the SD-WAN edge devices. One WAN Edge at HQ, one WAN Edge at the data center, one WAN Edge at each of the 3 branches, and one Cloud Edge or virtual SD-WAN router in the public cloud. We'll talk more about how the cloud regions are connected to the SD-WAN fabric, but for now let me just say that the cloud services typically offer you a virtual device you can configure yourself that acts as the edge device for your SD-WAN deployment. Now, each edge device connects to one or more underlay transports, such as MPLS, Internet, Fiber, 4G, 5G, and so on. Once all those components are in place, the SD-WAN overlay is built between the edge devices. Admins configure the management service, the control service pushes the configurations to the edge devices that conform to those configs that are applied, and when new edge devices want to connect, they contact the orchestration service to gain access to the fabric. After that, the branch LAN sends traffic to the local WAN edge, and the WAN edge looks at the routing information, policy, application, destination, and available paths. And then it forwards the traffic over the appropriate transport or overlay path. So if a branch user accesses a private application in the data center, traffic will go from the branch WAN edge to the data center WAN edge using specific policies that have been applied. If a user accesses a SaaS application, traffic will go directly to the cloud security service or to a cloud edge depending on the policy. If a branch communicates with HQ, traffic flows between those edge devices according to the SD-WAN design and policies that have been applied. So here are the key takeaways for this video. First, an SD-WAN deployment includes more than just routers at the branch. It includes management, control, and onboarding components. Second, those components may be deployed as cloud services, virtual machines, physical appliances, or vendor-managed systems. Third, the WAN edge devices are the devices that sit at the actual sites and forward user traffic. And fourth, SD-WAN centralizes the intelligence, but the actual traffic still flows through the edge devices. In the next video, we'll look more closely at how SD-WAN devices join the fabric, a process that is also known as onboarding. We'll talk about device identity, authentication, certificates, controller discovery, and zero-touch provisioning. That will help us understand how a device can be shipped to a branch, connected to the network, and securely become part of the SD-WAN fabric. Subscribe to the Telecom Tech YouTube channel so you can follow the complete series and enable notifications so that you can be informed when new videos are published. I'm Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. I hope this has been helpful for you, and I'd like to thank you for watching.